Guys, here's our first video notes. Let's see how this works. So, bell work. What are the three methods we use to solve systems of linear equations? Okay, go into your notebooks. Hopefully you are remembering that this is chapter 4. Okay, we had three methods. First one, graphing. And we did substitution, which we also called the cheerleader method. And finally, we had elimination. Hopefully you remember how all those work, because those are going to be very important today. Objectives for today, we're going to solve a system with linear and quadratic equations. Okay, so this is 9-7. We are solving systems of linear and quadratic equations. So here we go. Why are the solutions of a linear quadratic system of equations related to the solutions of a quadratic equation? So the first thing you're probably wondering is, what is a linear quadratic system? So a linear quadratic system of equations includes a linear equation and a quadratic equation, and is represented on a graph by their corresponding line and parabola. So we have a linear equation, there you see it in y equals mx plus b format, and we have a parabola, which this is in standard form, y equals ax squared plus bx plus c. So let's think about the number of solutions we have for a quadratic. We can either have 2, 1, or 0. Well, when we have a system, we can have the same amount of solutions. We can have a line that intersects a parabola at 0 points, 1 point, or 2 points. Okay, and remember, solutions are wherever the two lines intersect. So the first example we have here is when there's no solution. Okay, so we're looking at the green parabola and the purple line. Okay, obviously first graph, never going to touch. Second graph, also never going to touch. Okay, so that's what no solution would look like. One solution is where they would intersect only once. Okay, so looking at my first graph, right here is where my solution is. You could write that as the point 2, 0. Okay, my other graph looks like it's about right here, which would be the point 1, 1. And then finally, we also could have two solutions. Okay, notice the purple line and the red parabola. Okay, two solutions, one right here, one right there. Okay, those points are a little harder to see, so I'm not going to write them. And then over here, we got a point here and a point here. Again, I'm not going to write those points because those are decimals and I like to be accurate. Okay, so 0, 1, or 2 solutions. So let's look at an example. How many solutions does the system of equations y equals x and y equals x squared have? So I'm looking at this problem, and right here, this tells me that whatever point I pick has to be the same number. So x has to be the same thing as y. This tells me that y has to be the same thing as x squared. So when I square this number, I still get the same number. So, what can we think of? Well, negative numbers won't work because if I square a negative, it's going to become a positive. So we know we can focus on just the positive numbers. But what about 0? Let's think about the point 0, 0. Okay, looking at the first equation. Does x and y the same thing? Absolutely. And the second equation, y equals x squared. If I square 0, what do I get? 0. So yes, this is the solution. Another point you should be able to think of is the point 1, 1. Again, x and y are the same thing. If I take 1 and square it, I still get 1. So this problem has two solutions. Okay, well, that's all good and fun and good, but I don't want to guess and check every time. So we can do several different things. First thing we're going to look at is solving by graphing. So how can we use graphs to find the solutions of the equation 5 minus x squared equals x plus 3? Well, to do this, we're going to set each side of the equation equal to y and write the equations as a linear quadratic system of equations. So I'm going to take the stuff here on the left, and that's going to be my first equation. And I'm going to take the stuff here on the right, and that's going to be my second equation. Once I have these, it's just a matter of throwing them either in my graphing calculator or Desmos. I'll show you both because I'm assuming that most of us do not have graphing calculators at home. So let's start with the graphing calculator and then we'll go to Desmos because Desmos is easier. But here we go with the graphing calculator. So the first thing I want to do is go to y equals. Okay, clear anything out that you have in there. I already have these set up. Okay, so I would type the first equation in y1 and the second equation in y2. Once you have that, hit graph, and boom, there they are. Your calculator might be a little bit harder to count, so let's see if we can use the calculator to find the exact point. So, when we were looking for the 0, we use second calc. Goodness gracious, excuse me. We use second calc. Let's see if second calc has any other options. Oh, okay, I'm looking for value, now 0, now min, max. Ooh, look there, number 5 is intersect. Let's go ahead and see where they intersect. Okay, notice right here, it says first curve. Notice how up here, it's showing me that the blue line is what's selected. So I like that, so I'm gonna hit enter. Second curve, notice it's switched to the other line. So I'm gonna hit enter, and whenever it says guess, you always hit enter. And look, there's the point, -2, 1. So I'm gonna write that down. Our first point is the point, -2, 1. There's one of my solutions. Let's see if we can figure out the other solution. So again, second calc, intersect, and you can hit number 5 if that's easier. This time I want this point over here. So let's arrow until we're closer to that point. That looks about good to me. Enter. Red line good, enter. Guess, enter. Gives me the point 1, 4. So there is my second solution. Okay, so I should get 2 solutions for this problem. So that was the graphing calculator. Let's look at Desmos now. So again, I'm going to type my first equation into the first box. So y equals 5 minus x squared. Y equals 5 minus x squared. And I get the parabola. My second equation is y equals x plus 3. Okay. Oh, look, it gives me a nice little point where they intersect. So I'm going to click on those 2 points. Boom. Answers are exactly what we found with the graphing calculator. So that's how we do graphing. Okay, you try it. What's the solution of this equation? Rewrite the equation as a system of equations and graph to solve. Please take a minute, pause the video, and go ahead and try this problem. Okay, hopefully you've tried it. Let's see how to do it. Again, I'm going to take y equals. I'm going to take my first half, so x squared plus 1. And my second half is going to be my second equation, y equals x plus 3. From here, graphing calculator or Desmos. I'm going to go to Desmos just because it's easier to work with. So first equation, y equals x squared plus 1. Y equals x squared plus 1. And my second equation, y equals x plus 3. Oops, there we go. Click on the 2 spots. -1, 2, 2, 5. So my solutions, -1, 2, 2, 5. Easy peasy. Okay, so let's move on to another way to do this. Okay, sometimes graphing isn't always easy. I personally, if I don't have technology, I'm not going to pick graphing. So let's look at how to do this with elimination. So we want to find the solutions of the system of equations below. Y equals x squared minus 2x plus, or minus 6x plus 8, and y equals 2x minus 4. Now remember the elimination, we try to get one of the variables to cancel out. In order to do this, one needs to be positive, one needs to be negative. So looking at these, notice I have x squared and I have x. I can't cancel both of those, so x is not the equation I want to eliminate. Y would be the variable we want to eliminate. So, okay, positive y, positive y. I need one of them to be negative. I'm going to choose to make this one negative because there's a lot less going on in this problem. So I'm going to just rewrite this one really quick. Okay, and then remember here, you need to make sure you distribute everywhere. So I get negative y equals, okay, negative 2x. I'm going to line that up right with the other x's. And then -1 times -4 gives me a positive 4. Now, I can add straight up and down. Y minus y is 0. Okay, still just have x squared. -6x plus a -2x is a -8x. 8 plus 4 is 12. Okay, so I have 0 equals x squared minus 8x plus 12. From here, you have options. You can say, okay, do I want to reverse FOIL? Do I want to factor? Okay, so factoring, I could complete the square. I could do quadratic formula. Whatever you think is the easiest. I prefer factoring if I can, so let's see if we can factor this. 0 equals, okay, we'll do our 2 sets of parentheses because there's no GCF. How do I make x squared? X times x. Okay, now I'm thinking of two numbers that multiply to 12, and I can combine them to make 8. Okay, so 12, 1 and 12, 2 and 6, 3 and 4. Oh, 2 and 6 is my magic pair. Put a 2, put a 6. This sign tells you signs are the same, and they both get a negative. Okay, to finish solving, I now take this, split it down the middle, set each thing equal to 0. Add 2, x equals 2, add 6, x equals 6. Okay, we might think we're done here. Unfortunately, we are not. Remember, when I have a system of equations, I need points, x, comma, y. So I've got my x's, now I need to find my y's. So we're going to have 2 points. Okay, so if it's easier for you, put a box and you're going to list your points. 2, comma, something, 6, comma, something. How do I figure out my y values? Well, I have 2 equations. Let's plug them in and see what happens. Doesn't matter which equation you pick. Absolutely not. I personally think this one is easier because it's shorter. So I'm going to plug my x's into here. So the first thing I'm going to plug in is 2. So y equals 2. Instead of writing x, I'm going to write 2 minus 4. 2 times 2 is 4. 4 minus 4 is 0. So my first point is 2, comma 0. I'm going to do the same exact thing, but now I'm going to use 6. So y equals 2. Instead of x, I'm going to write 6 minus 4. 2 times 6 is 12, minus 4 is 8. So my second answer is 6, comma 8. Once you have your 2 solutions, you are done. Okay, your turn. Please pause the video and try to solve these. Okay, I'm going to go ahead and go through it. Hopefully you took the time to do this. Again, we want to eliminate. I am going to choose this because I always like my x squareds to be positive. So I get negative y equals positive x minus 4. And now I can add straight up and down. The y's cancel. Okay, no other x squareds, no other x's, and negative 6. Again, I'm partial to reverse foiling, so that's what I always try first. No GCF, so go ahead and do my 2 sets of parentheses. Okay, 2 numbers that multiply to 6, and I can make 1 out of them. 3 and 2. This tells me signs are different, and the bigger one gets the plus. So plus 3 minus 2. Again, got to finish solving. I'm going to split it down the middle. X plus 3 equals 0. X minus 2 equals 0. Minus 3, x equals negative 3. Add 2, x equals 2. Remember, I'm not done though. I have to solve for y. So I'm just going to write, okay, I'm going to take my equation. I like the top one, again, a little better. Y equals negative x plus 4. So negative x plus 4. And I'm going to plug in my 2 answers. So y equals negative, instead of writing x, I'm going to write negative 3. Careful here, negative times a negative is a positive. 3 plus 4 gives me 7. So I get the ordered pair, negative 3, comma 7. Do the same thing with my other answer. So y equals negative 2 plus 4. Negative 2 plus 4 gives me a positive 2. So I get the answer 2, 2. Here are my 2 solutions. Okay, please make sure you've tried the other problem. I'm going to go ahead and do this one. So again, I'm going to multiply the easier one. Let me rewrite the top one real quick though. Okay, my bottom equation becomes negative y equals negative 2, but I want to line it up. Okay, so the negative 2 would go down here with the positive 2. And then negative times a negative makes a positive x. Now I can add straight up and down. 0 equals negative x squared plus 5x. And the 2's cancel. Again, I am partial to factoring. If I look at this, oops, there's an x there, I forgot to write that. If I look at this, I have a GCF. So let's start by pulling out my GCF. I personally don't like the negative, so I'm going to pull out a negative x. I get x minus 5. From here, again, just split it down the middle. Negative x equals 0. X minus 5 equals 0. Remember, when you have a negative x, it's just like a negative 1 times x. So to solve, divide by negative 1. X equals 0. Over here, add 5. X equals 5. And remember now, you got to solve for y. So my equation is y equals 2 minus x. Let's plug in what we have. Okay, so I'm plugging in 0. So y equals 2 minus 0. Y equals 2. So I have the point 0, 2. Again, over here, now I'm going to plug in 5. Y equals 2 minus 5. Y equals negative 3. So I get the point 5 comma negative 3. And these are my 2 answers. Hopefully you did a good job with those. Okay, and the last way to solve system of equations we have is substitution. So here's a little bit of a word problem. Please don't groan. Say a phone company launches the sale of 2 phones in the same week. The phone on the top is an upgraded version of the other phone. During what week are the sales projected to be the same for both phones in thousands? What will be the weekly sales of each phone be for that week? Okay, so notice over here it says projected sales in thousands modeled by y equals 20x. So y is the money, or the sales, and x would be the number of phones. Okay, I think it's always helpful to list what your variables are so that you can remember that later. So first thing I'm going to do is I'm going to write these equations right beside each other so I can see them a little bit better. And I got y equals 20x, y equals negative 2x squared plus 60x. Now that says substitution. So remember, substitution we called the cheerleader method. I say y, you say 20x. So I'm going to take this 20x, and it's what y equals, so I'm going to stuff it in for the other y. So when I do that, I get 20x equals negative 2x squared plus 60x. Okay, now I don't know about you, but when I solve quadratics, I like to make it equal 0 first so I can see what I'm working with. So let's subtract this 20x. I get 0 equals negative 2x squared plus 40x. Oh, doesn't this look like the last problem? I have a GCF, so let's pull that out. I'm going to pull out a negative 2x, so I have x minus 20. From here, split it down the middle, set each thing equal to 0, and solve. Divide by negative 2, x equals 0, add 20, x equals 20. Okay, so I know, let's see, x is the number of phones. So I'm going to make the same amount of money when I sell 0 phones and when I sell 20 phones. Okay, but think about selling 0 phones. How much money are we going to make? Probably aren't going to make any money. So this is interesting, but not that interesting. But we need to use this to figure out how much money I make. So let's pick an equation. I think the y equals 20x is much easier to work with. So y equals 20x. First thing I'm going to do is plug in 0. So y equals 20 times 0. I get 0. So when I sell 0 phones, I make $0. Okay, now we're going to plug in 20. Y equals 20 times 20. So Y equals 400. So this means when I sell 20,000 phones, I'm going to make $400,000. Okay, and it's okay if you just leave it just like this, because they already told you that it is in thousands. This is the one that's most interesting because this one's pretty much common sense over here. If I sell 0 phones, I'm not making any money. So that's what I have for you guys today. So remember, we have 3 methods: substitution, elimination, and graphing. Okay, please make sure you're paying attention to the homework, what method it wants you to do, because I would like you to be able to do all 3 methods. Okay? And here's the homework. Page 401, you're going to do problems 15, 18, 20, 24 through 32 even. Please let me know if you have any questions on them. Please, again, try your best to get through them and let me know, and I'm happy to work any of them out. Hope you guys have a fantastic day. We'll talk to you later.